It says impulse originates around the AV node and travels antegrade or forward toward the ventricles and retrograde or backward toward the atria. So the impulse either goes forward or backward. Thus, it says the impulse travels in two directions. The AV junctional area can be divided into regions high, medium, or low. And whichever of these regions initiates the impulse will determine the location of the P wave. If the impulse originates high in the AV junction, close to the atria, it will arrive at the atria first and then write an inverted upside down P wave. So it's saying depending on where the impulse goes, right? So it's saying right now, if it's high, that means in the AV junction close to the atria, it will arrive at the atria first and write an inverted upside down P wave. The P wave is inverted because, let me see, I'm lost right now. The P wave is inverted because the impulse is going in backward direction to reach the atria. Then the forward impulses reach the ventricle and write the QRS complex. The PR interval is short, so the PR interval is going to be shorter, less than 0.12 seconds. Because the impulse starts out in the AV junction halfway to the ventricle, it simply doesn't have as far to go as the sinus impulses would. Bottom line. If the impulse originates high in the AV junction, the resultant rhythm or beat will have an inverted P wave proceeding before the QRS is preceding the QRS, and the PR interval should be less than 0.12 seconds. So the P wave is going to be closer to the QRS. So that's how you know when it's too close and have an inverted P wave, then that's when you know you have a junctional rhythm. It says that the impulse originates midway in the AV junction. The impulses will reach the atria and ventricle simultaneously at the same time because both are the same distance from the AV junction. Therefore, the P wave will be swallowed by the QRS complex. Bottom line for that one is mid-junctional impulses have no visible P waves. So you're not gonna see any P waves. You'll just see QRSs, narrow QRSs, not the wide ones, and then you won't have no P wave. That's how you know it's a junctional. If the impulses originate in the low in the AV junction, the impulses will reach the ventricle first, writing a QRS complex, then reaching the atria and writing the P wave. Thus, the P wave will follow the QRS, and since the impulses must travel backward to reach the atria, the P wave will be inverted. Bottom line, impulses originating from low in the AV junction have inverted P waves following the QRS complex. With what all that is saying is, you had a QRS, right? You have a QRS, and I just write it like that. Really, it's supposed to go like QRS, right, and like that. But I'm just you get what I'm saying. So it's either gonna be inverted and very close to the QRS, no P wave at all, or it's gonna come after the QRS and inverted, or it might inverted or something. Anyways, those will be junctional rhythms. Okay, these are gonna be junctional when the P wave starts acting. No P wave, and the QRS is narrow, or before the QRS, but inverted and too close, or after. That's when you're gonna have a junctional. It says junctional rhythms are seen less and often since sinus or atrial rhythms than sinus or atrial rhythms, and there are. I never really saw too many of those junctional rhythms, but you will see them. Although the inherent rate of the AV junction is 40 to 60 beats per minute, remember we said as you go further down the heart, it starts to get, the heart is not so healthy anymore. So now the sinus node, it's a healthy one. You get the regular 60 to 100 beats per minute. Well, now the junction, the heart's starting to beat slower. So that's going to be it. That's why I say, although the inherent rate of the AV junction is 40 to 60 beats per minute, the heart rate could actually be much faster or slower, which can result in symptoms. More normal heart rates are less likely to cause symptoms. So again, junctional rhythms are easy to identify. Let's look at the criteria which dictate a regular rhythm or premature beat with narrow QRS along with one of the following. So if you see an absent P waves with narrow QRSs, if you see inverted P waves following the QRS, or inverted P waves with short PR interval preceding the QRS, then you have a junctional rhythm. Just like a PAC that we talked about, where it's a premature beat, you also have, but this one's called premature junctional complexes, PJCs. These are PJCs, okay? Premature junctional complexes are premature beats that originate in the AV junction before the next sinus beat is due. This is like a premature beat. So it can occur anytime, regular but interrupted. So it can happen. You can see that the rhythm in this rhythm regular, because we'll get to that, because these rhythms are regular too, so they still look cute, and they're marching out for the most part. But you get, so this rhythm would be regular but interrupted, and you got a PJC here. And how do you know it's a PJC? Because you have a premature beat but no P waves. See, it says figure 9.2 shows QRS complexes all shaped the same. Regularity is regular but interrupted by two premature beats. See, and this one, the book gives you, it gives you the, I guess, the answer, so you can see that there's two premature beats. A heart rate is 71. The regularity is regular but interrupted. Heart rate, okay. P waves are matching and biphasic, except for the fourth and eighth beats, which are premature and have no waves. PR interval is 0.16 and QRS is 0.10 seconds. So this one would be called sinus rhythm with two PJCs. Sinus rhythm, because the underlying rhythm is still sinus because it has P waves to each beat. It's marching out. Its heart rate is in the 70s, so it's interrupted by PJCs. Okay. So an early beat is a PJC. Premature beat is a PJC. Junctional bradycardia. It's a rhythm that is less than 40 beats per minute. It's regular. It's a regular rhythm. The P waves would have an inverted P wave before or after the QRS, or hidden inside the QRS. That means no P, that you don't see a P wave, or you have an inverted P wave before or after the QRS, and the PR interval could be less than 0.12 seconds. QRS is still less than 0.12 seconds. PR interval is less than 0.12 seconds if the P wave precedes. So if you see a P wave before the QRS and it's very short, the PR interval is very short, most likely you have a junctional rhythm. And the heart rate needs to be less than 40 to be a junctional bradycardia. See, this is a bradycardia. You see how it's starting to look? So for the most part, it's not giving you too many beats, right? In 1 6-second rhythm. So you really can't tell too much if it's running regular. But for the most part, so far you can tell. but it's running very slow. See what I mean when I say the heart starts to get a little bit slower now. And like I said, it doesn't have a P wave in there. You don't see a P wave. You just see a QRS. And it's 1, 2, 3. Heart rate is 30. So junctional bradycardia is anything under 40 beats per minute. A regular junctional rhythm, it's anywhere from 40 to 60 beats per minute, and it's regular. It's still marching out. And P waves, it has to be inverted before or after the QRS, or no P wave at all. The PR needs to be smaller than 0.12 seconds if it precedes the QRS. If you see a P wave before, it needs to be smaller to be considered a junctional. QRS is still going to remain the same, less than 0.12 seconds. This is a junctional rhythm. It's still regular. You can 100% see that it's still marching out. It's still narrow. The QRS is still narrow. 1, 2, 3, 4, 5, 6. You have 6. This is something about the book. You don't pay attention to this. So it's 6. So it's 60 beats per minute. So it's within the ranges of the regular junctional rhythm. And you don't see a P wave. So most likely this is junctional. The accelerated junctional rhythm, it's almost as the accelerated junctional rhythm. It's almost like a normal sinus rhythm. A normal sinus rhythm is between 60 to 100 beats per minute, and it's regular. These two are almost the same thing as a sinus, except the P wave. See? Accelerated junctional rhythm is almost like a sinus, regular with narrow QRSs, except like we said, no P waves. We don't see any P waves. Or would it be, what do we say, inverted before or after the QRS, or no P wave at all, because it's going to be hidden in the QRS, it says. PR interval, less than 0.12 seconds if the P wave is before the QRS. QRS, like I said, still remains. It needs to be less than 0.12 seconds. Those little, right? Just so you can remember. So that's an accelerated junctional rhythm. Junctional tachycardia, to me, I still sometimes have to look at the rhythm a lot, because sometimes it looks like an SVT, because it says you cannot see the P wave, but if you pay close attention, you can see an inverted P wave after the QRS. You see that? An inverted P wave, and then you see a little T wave. So that's how you know this is, and it's going to be, so junctional tachycardia. Tachycardia means fast, right? Greater than 100 beats per minute. It's still regular. You see this? It's still regular. Except the junctional is like really messing with how you know it's with the P wave. So if the P wave starts to look funny, then most likely a junctional. But 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oops. Yeah, 12. So it's got to be greater than 100. It should still be regular looking. Again, the P waves, it's got to be inverted before or after the QRS, or hidden inside the QRS, or like I said, no P wave. PR interval needs to be less than 0.12 seconds if the P wave precedes the QRS. If you see one, it should be less than 0.12 seconds. So it should be like, if you see a P wave here, it needs to be really close to the QRS, less than 0.12 seconds. QRS still remains the same, less than 0.12 seconds. Let's look at a few strips. So this one, like I said, this was when I was learning. So you'll see some notes when I was learning. So you see QRSs, you see that they're regular, but you don't see any P waves. So that's a junctional, right? And it's counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now this is greater than 100. I put accelerated junctional rhythm. So for the most part, I guess, let's see, you could probably put, I put junctional rhythm, but it probably was accelerated. What did I put? Yeah, I did. Accelerated junctional rhythm. Okay, sorry. That was my bad. So accelerated junctional rhythm, that's what that is. And QRSs are upright, the regular heart rate, like I said, no P waves. So you know that's junctional. Let's see what we have over here. They're all marching out. You get one premature beat here, but you don't know if it's PAC, PJC, or PVC. But how would you know? Because there's no what? P waves. So everything else is marching out, right? Except this premature beat. You have to pay close attention because you have to see, because there's so many, you got so many different rhythms. You got to make sure that you see the P waves, that you see the QRS, that they're all marching out within around the same amount of the squares between them. That you see a premature beat. So the underlying rhythm would be, let's count 1, 2, 3, 4, 5. We're still gonna count this one here, but let's see what it will be at the end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 100. So it's a sinus rhythm because you see a P wave. They're marching now. So the underlying rhythm is sinus rhythm, but it's interrupted by PJC. See, sinus rhythm with a PJC. The QRSs are upright. Regularity is regular but interrupted. Heart rate. Okay, so it's just it just wants you to fill in the blanks here. So PR interval 0.16. So the underlying rhythm is good. It's just that PJC. Let's look at this one. 1, 2, 3, 4, 5. Right now we know we're working with junctional, so it gives you a big clue, right? So you got 5. Heart rate is 50, right? Because you times it by 10 or just add the 0 at the end. So 5. So his heart rate is 50. It's a junctional because you don't see any P waves anywhere. So we have a junctional rhythm because a regular junctional rhythm is anywhere from 40 to 60. That's what a normal junctional rhythm is. Let's see what this is in the bottom. So it's beating slow. This heart is beating slow. 1, 2, 3, 4, 5. It's a sinus. It's just beating slow. So what's a sinus rhythm that beats slow at 1, 2, 3, 4, 5? Sinus Brady. And it's, you see that PJC? It's interrupted. So it's a regular rhythm. For the most part, you see that these are marching out. It would march out here too, except it has a premature beat. So that's a PJC because that P wave is inverted. So you got a sinus Brady with a PJC. That's how you would interpret that. What is this one? 1, 2, 3. For the most part, I guess it's marching out. It's a junctional rhythm. So what is that? Junctional Brady or junctional bradycardia. Heart rate is 30 beats per minute. 1, 2, 3. Add a 0, 30. Let's look at this one. What do y'all think this is? You still count this one, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 150 heart rate, you can see the P wave. So sometimes with these, I want to say SVT, but it's I'm sorry, either junction, what is that, junctional tachycardia or SVT. But I think for junctional, if you want to call it junctional tachycardia, I think you still have to see some type of P wave in there to call it that. So for this one, just call it an SVT because it's running pretty fast too. See, this one, it tells you a little bit better. Junctional tachycardia with no P waves is best called SVT. So if you see a P wave in that one where, is running too fast, but you can't tell if it's junctional tachycardia or SVT, it says best to call it SVT. If you see an inverted P wave in there, or it's close to or you see one before or after the QRS somewhere, then you know most likely it's a junctional tachycardia, so inverted or too close to the QRS. But since there is no proof that there is even P waves there, so just call it SVT. So no way to know the rhythm's origin for sure. So if you see one of those rhythms, just call it an SVT.